In this video, we will be talking about greenhouse gases. The atmosphere is a thin layer of gases that surrounds the planet. The Earth's atmosphere is about 78% nitrogen. It's about 21% oxygen and 0.9% argon. The remaining 0.1% consists of other gases. These other gases include methane, ozone, water vapor, carbon dioxide, neon, helium, and various oxides of nitrogen, and a few other gases as well. Methane, water vapor, carbon dioxide, and a couple of the others are what we call greenhouse gases. Greenhouse gases are able to trap heat, and they keep the planet warmer than it would be if there were no greenhouse gases. If we didn't have greenhouse gases, the average temperature would be negative 18 degrees Celsius. That's about 0 degrees Fahrenheit. With temperatures this cold, much of the life on our planet would not exist. But how do greenhouse gases work? Most of the light coming into the Earth's system comes from the sun and consists of visible light, which we can see, and ultraviolet light, which we can't see. This light can easily pass through our atmosphere and all the gases in it. But after the light strikes the Earth, it is radiated back as infrared radiation. We can't see infrared radiation, but we can feel it as heat. Let's use this PhET simulation to see what happens when light hits different molecules in our atmosphere. We'll start by bombarding molecules with visible light. Notice that the visible light just passes right through. We'll do the same thing with ultraviolet light, and we notice that most of our molecules just seem to ignore it and let it pass right by them. Now, let's bombard these molecules with infrared radiation. Notice how it does not seem to have any effect on oxygen molecules or nitrogen molecules. However, let's look at carbon dioxide. When the carbon dioxide molecule is bombarded with infrared radiation, the radiation is absorbed, and the energy makes the bonds in the molecule vibrate. Eventually, the molecule re-emits the light as infrared radiation. Notice how the light is scattered in random directions. We see the same phenomenon when we bombard methane with infrared radiation, and when we bombard water vapor with infrared radiation. When the infrared radiation is re-emitted or radiated back out from the greenhouse gas, some of it goes back into space, some of it is absorbed by other greenhouse gas molecules in the atmosphere and eventually re-emitted, and some of the infrared radiation comes back to the Earth, and the absorption re-emission cycle continues. The result is that heat gets trapped in our atmosphere near the surface of our planet, and our planet gets warmer. As I mentioned earlier, these greenhouse gases are present in very tiny amounts, but even these tiny amounts play a big role in the warming of our planet. Although many greenhouse gases occur naturally in our atmosphere, human actions like burning fossil fuels and deforestation are increasing the concentration of these gases. When we add more greenhouse gas molecules to our atmosphere, the atmosphere traps more heat, and the planet gets warmer. Let's take a closer look at some of these greenhouse gases. Carbon dioxide only makes up about 0.04% of our atmosphere, but it's one of the greenhouse gases that we're most worried about. Carbon dioxide is released through many natural processes, such as animal and plant respiration and volcanic eruptions. However, because of human actions, such as the burning of fossil fuels and deforestation, the carbon dioxide in our atmosphere is increasing. This graph of carbon dioxide measurements shows how carbon dioxide levels are going up. The carbon dioxide in the atmosphere has increased about 50% since the Industrial Revolution began in the 1800s. This extra carbon dioxide is leading to a gradual increase in global temperatures. Methane is another greenhouse gas. It is naturally released when animals and plants decay. However, human activity is causing more of this to be pumped into the air. Lots of methane is released from waste dumps, rice farming, cattle farming, and the production of oil and gas. Water vapor is the most abundant greenhouse gas, but it's very different from greenhouse gases like carbon dioxide and methane. Water vapor doesn't last in the atmosphere for very long because it can condense and turn into rain or snow or ice as part of the water cycle. Unlike with carbon dioxide and methane, humans are not directly adding more water vapor into the air. But as the Earth gets warmer, more water will evaporate. It won't be able to condense and precipitate as easily as it does when the temperature is colder. The water vapor will stay in the atmosphere, and because it is a greenhouse gas, it will trap heat. This will cause the temperature to increase even more, enhancing the greenhouse effect. Water vapor is not causing climate change, but it's playing an important role in feedback loops that can make climate change worse. We'll talk about feedback in a future video. In summary, greenhouse gases are gases in the Earth's atmosphere that are responsible for trapping heat and keeping the planet warmer than it would be if there were no greenhouse gases. Carbon dioxide, methane, and water vapor are important examples of greenhouse gases. Human activities are causing atmospheric greenhouse gases to increase. This is resulting in increasing global temperatures.